Okay, it's about 2 o'clock, the 8th of February, 2005, and went ahead and re-welded these fang teeth back on here. Had to weld the hell out of them, and using that ready welder really is difficult at times because the wire just gets bound up inside it. And anyway, I had to do like 4 or 5 passes of welds on this thing with 045 wire running off my 2 main batteries on the timberjack over there, 24 volts. But anyway, as you can see, there's quite a hefty weld on there. Hopefully it'll hold. These help me to chop up the material underneath the disc without getting all the rest of these teeth here into the dirt and rocks, because these stick down by about 5 or 6 inches. At any rate, I was thinking about modifying this structure. I like this arm here, and as you can see, it does get some material underneath it and get trapped. Making improvements to this design, I think, would be best to remove this structure here altogether and replace it with just an arm that comes off of this point here and shoots outward, kind of like my arm, so that the material still can get full exposure and friction from the top of this wheel, and then it can drive it right into the structure that would stand out right here, basically. So what I'm finding is the limbs are so wide that they get stuck on top of here, and a lot of times it just doesn't go down in there. However, this is very effective at trapping material in here. Trees just like this get caught in there, and it gets sucked right in, basically. And then this tooth right here chops at the material before it leaves. I really ought to have something right in here even. But this is a good structure. I just don't like the way it looks right here. Maybe moving it down to the edge will give it the same effect, even better effect, because I would have more ability to get friction, shear properties, pulling the material into the shear zone, friction, and then shearing. More surface area makes all the difference. But the bearings are holding up just fine on this machine. I don't know how many hours I have on it now. It's about 69.99, about 7,000 hours on this machine now. I believe when I bought the machine I had 6,714 or so hours. So I put about 300 hours on it then, almost. Anyway, I'm going to eat lunch and hit the grinding, hit the hills and do some grinding. So we'll see how these teeth do. Got to keep them out of the stumps though, those big fang teeth. The stumps are very hard. I think I will actually install some large whiskers off of here, big cables that come out and up like a big whisker. What that'll do is it'll help hold the material from flopping, but yet keep it somewhat upright so where the friction and shearing can take full effect. So those whiskers will just simply act as guides and supports, but yet they're flexible and they can bend over, and I'll just have to find some kind of a fixture that I can put cables here, clamp them in, and weld those fixtures down, and I'll have the whiskers come out about like so. They'll come way out like this, but yet they'll be able to flex inwards, but yet not touch the teeth, because I don't want to shear that. We don't want to shear cables. It would create lots of sparks and lots of metal fraying. But I built up some of these teeth here so they're a little sharper just by adding a little weld to them. That ready welder works, except when it gets hot it just kind of binds up inside, doesn't feed out the 045 flux cord wire, because that wire is so stiff. It's very hard wire. These teeth are holding up really well. The bottom of the tool holder is getting worn off, but these are experimental teeth. These are used for grinding rock and concrete on highways. Planer teeth, road planer, and tipped with tungsten carbide, which holds up just fine. In fact, hit something like these, it just makes it sharper, as where these get much duller. So it's nice to have a sharp point tooth. It's a trade secret of mine. And these teeth actually cost less money than these, as well as these. These are less money than the Quadco tooth, beaver style.